Hi everyone, we are Group 1 from the SEB65A, and today we are pleased to present our final project for the Database Management System course, which is Library Management Systems, and our group consists of 4 members: Hàn Chí Kiên, Chu Bích Phương, Nguyễn Thanh Thảo, and Phạm Hồng Minh. And I have a question for everyone. Have you ever felt lost in a sea of books or wonder how complex information like library records are actually managed effectively? Well, that's the power of a great database systems, and for our final project in this course, we built the solutions, which is library management systems. So now let's come with Bích Phương to discover the objective of this project. Primary objective of this project is to design and develop an effective digital system to manage core library operations. We aim to simplify processes like borrowing and returning books, and importantly, to enhance the user experience through an efficient information retrieval and management systems. To achieve this, we utilize MySQL as our database management systems for robust data storage in Python with the MySQL connector Python library for the application's backend logic and user interface. And our system isn't just about storing data, it is packed with essential features that keep our library operations running smoothly and efficiently. So let's break it out. 1. Book management. User can add, edit, delete, or search for book in the library. 2. Category and author management. 3. Reader information management. User can register or update the information. 4. Borrowing and returning book management. 5. Overdue book alerts. And the last one is the statistical reporting about books and readers. So for the next part, let's come with me to the database design explanation. We will have the entity relationship diagram or the ERD. This diagram helps us map out the core entities that make up our library's digital structure, which includes authors, books, categories, readers, and borrowing tables. And the borrowing entity acts as an associative table. This is a key. It connects readers and books in a many-to-many relationship. So one reader can borrow multiple books, and a book can be borrowed by multiple readers. Following the ERD, we translated this conceptual model into a concrete relational database schema. Our schema comprises 5 main tables: authors, categories, books, readers, and the borrowing table. Each table is uniquely identified by a primary key, for example, the book ID in the books table or reader ID in the readers table. These are auto-incrementing integers, making each record easy to identify. To ensure data consistency and integrity, we have established foreign key relationships. For example, in the books table, author ID and category ID are foreign keys that reference the authors and categories table respectively. This guarantees that every book entry is associated with a valid author and category. By designing our schema this way, we make sure that it keeps our database clean, reliable, and ready to scale. To enhance performance and functionality, we have implemented several advanced database objects. First, indexes. To ensure rapid data retrieval, we have indexed regularly search columns like book name and reader name, as well as key date columns in the borrowing table. This dramatically speed up queries. Next, views. We created views like View Available Books, which prejoins table and filters data. For instance, to show only books currently in stock, this simplifies complex queries needed for application features and reports. For critical operations, we use store procedures. Our SP borrow book procedure is a prime example. It encapsulates all the complex logic for borrowing a book, including validation checks, ensuring atomicity with transactions, and using for update to prevent race conditions when checking book quantity. This centralized business rules within the database itself. We also utilize a user-defined function, fn calculate current overdue days. This UDF handles the specific calculation of how many days a book is overdue, making our overdue reporting queries cleaner and more readable. And finally, triggers. These are crucial for automating actions and maintaining data consistencies. For instance, TRG after borrow insert automatically decrements a book's quantity in the books table right after a borrowing record is inserted. A similar trigger handles incrementing the quantity upon return. This ensures our stock levels are always accurate without needing extra application code. Together, these advanced objects make our database more efficient, robust, and intelligent.
Now, let's look at the Python application that interacts with our MySQL database. we use the MySQL connected Python library. Secure credential management is implemented using environment variables loaded via python.env. For efficiency, we have set up a connection pool, and connections are managed using try except finally blocks, with cursors handled by with statements for automatic resource management. Since each function in our systems follows the same implementation pattern, we establish a consistent workflow. First, we prepare the appropriate SQL statement for the action, for example, insert, update, and select. We then establish a connection using getDBConnection function and create a cursor to execute SQL command. If the operation involves data changes, we commit the transaction to save those changes to the database. And finally, we always close the connection to free up resources and maintain application performance. Next, let's explore the book management feature, which plays a central role in our system. This functionality allows us to efficiently manage all book-related information in the library. Users can perform the following operations: adding, retrieving, updating, and deleting books, also known as CRUD. First, regarding adding function, the function addBook takes in several details: book's title, author ID, publication year, quantity, and the category ID. It prepares an SQL insert statement yielding those values and adds the new book to the database. This function helps us expand our library collection with just one command. For retrieving method, we have implemented two Python functions for this purpose. First, fetching all books with getAllBooks details function. This function doesn't take any input, it simply pulls together complete book details from multiple tables, books, authors, and categories. Internally, it executes an SQL select statement that joins information from three tables, books, authors, and categories. This allows us to gather not just the book title and quantity, but also the author's name and the category name, all in one go. The results are ordered by book name for easy browsing. The function then returns these results as a list of Python dictionaries. Each dictionary represents a book and contains key like book name, author name, category name, published year, and quantity. Second, fetching a specific book by its ID with getBookDetails by ID function. This function takes one specific input, book ID of the book we want to look up. Its purpose is to fetch all available details for that single identified book. Similar to the previous function, it uses an SQL select statement that joins the books, authors, and categories table. The SQL query is almost the same as before, but includes a where clause to filter by book ID. If a book with that ID is found, the function then returns a single dictionary containing all its details. If no book is found, it returns none. Moving on, we will cover how to update the details and quantity of a book in the system. We will use two functions, updateBookDetails and updateBookQuantity. The updateBookDetails function is used to modify the core information of a book like its title, author, publication year, or category. Internally, it constructs a SQL update command. The set clause specifies which columns to change with the new values, and the where clause ensures that only the record for correct book is modified. After executing the command, commit to make the changes permanent in the database. The updateBookQuantity function changes the quantity of a book by a given amount. This function takes two inputs, the book ID and the quantity change. This change can be positive to add copies or negative to remove copies. The purpose is to directly modify the quantity field for a specific book. The system ensures that the quantity never drops below zero by using the SQL greatest function. And finally, if we need to remove a book, we use the deleteBook function. It takes the book's ID and runs an SQL delete command to remove it from the database. Simple and effective. Translating that backend power into a user-friendly experience, here is the book's management interface. On this screen, you can see a comprehensive table listing all the books. The columns display key details like ID, title, author, category, published year, and quantity. Information pulled efficiently using our retrieval functions. For flexibility, you can control how many books are displayed per page, with options for 10, 25, or 40 results. Easily find specific books or narrow data list using the search bar at the top, which allows searching for books by name, author, or category. You can also sort the table by any of these attributes. Simply click on the column's header to order books in ascending or a descending order. To add a new book, just click the prominent Add New Book button. A form appears when you input necessary details, which our add book function then processes and inserts into the database. For existing entries, each row features Edit and Delete buttons. Clicking Edit allows you to modify book details and quantity, utilizing our Update Book Details and Update Book Quantity functions. Our system includes a safeguard here. If a book has current active borrowers, a warning will pop up reminding you about potential impacts on borrower records, requiring confirmation to proceed. The Delete button triggers our Delete Book function, but with smart validation. If a book has never been borrowed, a simple confirmation removes it. If it has past borrowing records but no active loans, a double confirmation is required, acknowledging the history. However, if there are active borrowers for the book, the system prevents deletion and displays an error message to protect ongoing transactions.
Next feature of our system is category and author management. It also follows CRUD functions. First, we have adding. The function add category inserts a new record into the categories table. If the category name already exists, we should violate a unique caution, an error message is displayed. Next, we have get all categories, which fetches all categories from the database and returns them in alphabetical order. We can also retrieve a single category using getCategory by ID. This is useful for updating or displaying category information. To update an existing category, we use update category function with two inputs, a category ID and new name. The SQL update command modifies the category name field where the ID matches. Behind the scenes, these actions use standard SQL insert, select, and update commands with our Python functions, much like we saw with book management. For adding and updating, we ensure category names remain unique to prevent duplicates. And finally, delete category removes a category using its ID. This executes a SQL delete command when we catch any errors if the category is still linked to the books in the system. Maintaining an accurate list of authors is just as important. The management of authors follow the same fundamental CRUD principles we have seen for books and categories. Librarians can add new authors to the system, view the complete list of authors, retrieve an author by their IDs, and update author names if corrections are needed. As with other entities, these operations utilize standard SQL insert, select, and update commands within our Python functions. For instance, adding an author involves inserting their name into the authors table. Authors can also be removed from the system. Similar to categories, there's a crucial data integrity check involved. The system prevents the deletion of an author if they still have books linked to them in the database. This is enforced by a foreign key constraint and handled gracefully in our Python code to avoid orphan book records. If an author has no associated books, they can be deleted. This ensures that every book in our library always has a valid, existing author, maintaining the integrity of our collection data. After performing operations such as adding, updating, or deleting, a notification will appear in the top right corner of the screen to indicate the result. Now let's see it in UI. Within the author category GUI, you'll find a flexible pagination with options for 10, 25, or 40 results per page, alongside a search feature to locate items by author or category ID and name. You can also add new authors or categories, sort existing ones in ascending or descending order, and edit or delete specific entries, provided no books are currently associated with them. Our library system also needs to manage its member or readers. The operations for readers, registering new ones, reviewing member lists, updating details, and removing members follow the familiar CRUD pattern. We can easily register new readers by inputting their name, address, and phone number. The system also allows us to view a complete list of all registered members, find readers by their IDs, and update their information, such as a change of address or phone number, as needed. These actions use the standard SQL insert, select, and update commands. A specific consideration for readers is that the phone numbers are typically unique. Our system handles potential integrity error if a duplicate phone number is entered during registration or update. Readers can be removed from the system. However, the system prevents the deletion of a reader if they have any active or past borrowing records linked to them. This is enforced by a foreign key constraint to ensure our borrowing history remains intact and accurate. If a reader has no borrowing history, their record can be deleted. After performing operations such as adding, updating, or deleting, a notification will appear in the top right corner of the screen to indicate the result. Now, let's see it in UI. For the reader's GUI, you have 3 options for displaying a result per page: 10, 25, or 40, and you can sort the list in ascending or descending order. Search effectively by entering a reader's ID, name, address, or phone number. Additionally, you can add new readers and edit or delete specific readers, with the important note that current active readers cannot be deleted. Now we arrive at 2 of the most critical and frequently used functionalities in any library: the process of borrowing a book and returning it. These operations involve several checks and updates to ensure library data remains accurate and consistent. First, let's talk about borrowing books. Our Python function borrowBook takes the reader ID and the book ID as input. Its primary purpose is to act as a clean interface to a more complex operation handled directly within the database. It also calls a database store procedure named borrowBook. This procedure is the brain of the borrowing operation. It performs crucial checks: reader validity, book existence, and current stock availability. Importantly, using select for update to prevent issues if multiple librarians try to borrow the last copy at the same time. It also ensures that a reader doesn't borrow the same book twice if it's still out. If all checks pass, borrowBook uses a database transaction to safely insert a new long record into the borrowing table. Immediately after this successful insertion, a database trigger automatically fires and increments the book quantity in our inventory. This keeps everything synchronized. When it's time to bring the book back, we use the returnBook function. This also takes 2 parameters: reader ID, who's returning it, and book ID, which book is being returned. In this case, our Python function directly sends an SQL update command to the borrowing table. This command sets the return date to today for the specific active loan, identified by the reader and book, and ensuring that the return date was previously null. After this update is committed, another database trigger after borrow update automatically activates and increments the book's quantity in our inventory. The return is recorded, the book's return date is set, and its available quantity is immediately increased, making it ready for the next borrower. This automated trigger-based approach ensures our inventory is always accurate. Once the book is returned, a message will confirm the successful return. Another powerful utility for librarians is the book borrower's lookup. This feature allows them to quickly find out who currently has a specific book checked out and see its borrowing status. By searching for the book title, the librarian can view the information of the borrowers as well as the borrowing status of each person. Moving to the Borrow Return GUI, this section features 3 main parts: borrowing, returning, and borrower's lookup. To borrow a book, you type to search and select a reader, then choose an available book where its remaining quantity is shown, and proceed to borrow. With a toast notification, you receive an error if they try to borrow a book when they're already borrowing that book and haven't returned it yet. When returning a book, you select a reader, and the system automatically sorts out which books they are borrowing along with the borrow date, and they can return it. Lastly, the borrower's lookup allows you to type to search and select a book, which will then display its information along with its current borrowers and any who are overdue.
Our library system also provides key insight through statistical reporting, helping librarians monitor the collection and track borrowing patterns effectively. Let's look at some core reports. First, the available books report. The report available book function lists all titles currently in stock. It queries a database view, available books, which eventually gathers data on books with a quantity greater than 0. On our reports page, the available books tab displays the data. You can see key details like book name, author, category, year, and current quantity. This gives an immediate overview of our available inventory. Next, the currently borrowed report, generated by the report currently borrowed function. It shows all books presently on loan. It also uses a dedicated database view, currently borrowed, joining relevant tables to list books with no return date yet, and it calculates the due date. In the UI, under the currently borrowed tab, we see each borrowed book, the reader's name, borrowed date, and its due date. It is essential for tracking circulation and upcoming returns. Managing overdue books is crucial. Our report overdue books function helps with this. This function connects to the database and calls a store procedure, report overdue books, efficiently identifying overdue items based on a loan period, which defaults to 14 days but can be adjusted. In the reports UI, the overdue books tab presents this. Librarians can input a specific loan period if needed. The table then clearly lists the reader, overdue book, and importantly, how many days overdue it is. And to understand reading trends, we have the popular books report, generated by the report popular books function. Unlike previous reports using views or store procedures, this function executes a direct SQL query. It counts how many times each book appears in the borrowing table, groups the count, and then orders them to show the most borrowed titles first. The limit clause let us easily see a top-end list. On the UI, the popular books tab displays this ranking. You can see the book name, its author, and the total borrow count. Users can also specify how many top books they want to see. This helps the librarians identify high-demand titles for collection development or promotion. Now, let's explore the heart of our system user interface, the dashboard. This is designed to provide librarians with an immediate and comprehensive snapshot of all key library activities and statuses. Upon logging in, a personalized greeting welcomes the librarian. For optimal screen use, the sidebar navigation can be easily toggled. The dashboard is organized into intuitive sections for quick insights. At the very top, the overview section presents vital statistics at a glance: total books, readers, categories, and authors. Alongside these, we have dynamic counts for currently borrowed books and the total number of overdue books. To make these numbers even more digestible, we have incorporated visual percentage charts. The available books chart gives a quick sense of our collection's lending capacity, showing books in stock versus those fully checked out. Next to it, the overdue books chart visually represents the proportion of currently borrowed books that are overdue, helping to quickly gauge the urgency of follow-ups. Moving down, the popular books section showcases the library most sought after titles. This table displays the top books, ranked by the total number of times each has been borrowed, offering valuable data for collection development. And to understand recent activity, the borrowing trends section provides a dynamic chart of borrowing and return patterns. Librarians can filter this view by week or by month to identify peak times or shift in library usage. And finally, complementing the overall overdue count from the stat cards, the dashboard features an overdue book snapshot. This table provides a quick look at specific overdue items, including the reader, book details, and how many days they are overdue, allowing for immediate attention to pressing cases. Beyond access control, general data security is also very important. We employ secure credential management using .env files, and all Python database interactions use parameterized queries to prevent SQL injection. Further details on proposed network hardening and data encryption are in our report. For backup and recovery, our strategy includes daily automated backups via MySQL dump, with these backups stored securely off-site. Crucially, we've outlined regularly tested recovery procedures to ensure data resilience. And finally, performance optimization is achieved through selective indexing on key tables and columns, along with the use of efficient queries, leveraging views and store procedures, as well as the application-level connection pooling in Python to keep the system responsive. These measures collectively contribute to a secure, reliable, and performing database backend. In conclusion, this project has successfully delivered a functional library management system. We've met the core requirements for managing books, readers, and borrowing process. The system is built on a robust Python and MySQL backend, optimized with views, stored procedures, and triggers. it provides valuable operational insight through detailed reports in the central dashboard, fulfilling our primary objective for effective library administration. Looking ahead, there are several exciting refinements for future improvements. Firstly, deploying the system to a cloud environment would enhance accessibility. Secondly, implementing a more granular role-based access control, differentiating between librarian and reader's permissions, will significantly improve security and user experience. And thirdly, integrating third-party authentication like Google OAuth could offer greater convenience. Beyond these, further developments could always include advanced reporting, UI refinements, and new features based on evolving library needs. Thank you for listening.